We live in a time where science plays an important role in society. We also live in a time of scientific pluralism, and there are big divides and disagreements among scientific positions. At the same time, science is going into more fields, involving more researchers and using a larger repertoire of methodologies and methods than ever before. Furthermore, we live in a knowledge society where there is conflicting interest and conflicting knowledge, but where we are also dependent on a common reason.
How can science be diverse and contribute to pluralism in society and at the same time provide valid knowledge? In order to try to answer this question, I will take you on a journey through the history of European science and make a few stops on the way and look at how philosophers and scientists at different times have tried to understand what science is.
In this first part of our journey, we will look at how science emerged in the antiquity, how it was rediscovered in the medieval time, and how it gradually became an independent institution in society. Along the route, we will look at how science has been understood and conceptualized. The roots of today's science can be found in Greece, in the antiquity, at the Academy in Athens around 350 BC. The Academy was founded by Plato and was a school for higher education. It got its name from the place in which it was located, a place that was dedicated to Athena, the goddess of wisdom. One of the Academy's most prominent students was Aristotle. The works of Plato and Aristotle would become the most important references for science up to modern time.
They were struggling with trying to understand this whole phenomenon of general concepts. Where are they? What are they? Are they real? Are they not? So it was that was not only a controversy but a discussion that has followed, science and philosophy for 2,000 years.
This discussion should turn about to be the first big controversy in science that still defines some of its most fundamental disagreements. The Renaissance painter Raphael captured this disagreement between Plato and Aristotle in his painting of the Academy, letting Plato point upwards towards the ideas, while Aristotle points downwards at nature. What was this disagreement about? And why is it so important? As we shall see, the disagreement would be a major divide in scientific reasoning up to modern times.
There were differences, obviously. I mean, Plato was very much concerned with his own conception of ideas or forms that were, in a way, standards of measurement for things here on Earth. There was for horses and human beings and everything, there was a sort of ideal type idea existing separately. And Aristotle was very much in disagreement with this. He had a different thoughts about the status of these forms or ideas.
The disagreement escalated because it had also implications for how to do science. Plato believed in reasoning from ideas. Aristotle believed that in order to understand the forces that govern nature, we need to study nature itself. And for some reason, this disagreement led Aristotle to the Greek island of Lesbos.
It's quite a coincidence why Aristotle ended up here in Calonie Bay. The story is told that it was a dispute with the nephew of Plato, Speusippus, when he took over the academy in 347 before Christ. And the dispute was about methodology. If that is the case, it's actually the first big methodological dispute in science. He came here because his student, Theophrastus, lived in this island, and Theophrastus was interested in botany. Here Aristotle discovered biology because obvious of the fantastic wildlife and animal life and sea life that he discovered in this bay. And together they made works that became reference for these scientific fields for centuries after.
Aristotle wrote several books where he classified political systems, literature, ethics, and nature.
So Aristotle was actually the first to systematically start to research the natural world in a way, in a scientific way, if you like.
Plato believed that we can know how things logically have to be, even if we cannot observe them. Aristotle used his observation to put both the nature and the human world into categories that would reveal the natural order of things. And he described this eternal order. So, in spite of their science and differences, the antiquity had the world picture that everything was governed by divine forces. After antiquity, science decayed, and it would go 1500 years before Aristotle was rediscovered in Europe. The migration period in Europe from the fall of the Roman Empire to the early Middle Ages was marked by profound changes. It was also a period when science was ignored, ideas forgotten, and books simply locked away.
After a long period of decay, there is a renewed interest in science in Europe, and it manifests itself around 1150 with the establishment of the new European universities, first in Bologna and then in Oxford and here in Paris.
Universities derive the name from a Latin concept of community of teachers and scholars. The universities grew out of clerical school that got permission to give higher education. In the Middle Ages that followed the Roman Empire, the Church gradually built and rebuilt institutions in Europe. It was the Church that controlled the teaching institutions where intellectual discussions took place. By this, the Catholic Church gained control over science.
The Church was sitting on all authority in Europe. At the Church, in the Church institutions, was the libraries, the learned people, the researchers, and of course the theologians. And the Church had its hand of all kind of knowledge.
The Church was in a dilemma. It supported development of knowledge, but for natural reasons would not allow ideas that could compete with the Bible and their world picture. In this picture, the earth was in the center, and everything was ranked according to its relation to God. However, after 1100, the Church started to take a more liberal view on what was acceptable. Aristotle was again relevant.
And the good intention behind this is that the Church should care about nature. And who was the expert on nature? It was, of course, Aristotle.
One of the scholastics that influenced the way the Catholic Church adopted Aristotelian thinking was Thomas Aquinas. In the mid-1200s, he came to the University of Paris, first as a student, and later as a teacher. He found that the systematic logic of religious thinking could be combined with Aristotle's method of classification. He wrote, "It is natural to a human being to attain to what is intelligible through objects of senses, because our knowledge originates from senses." Now a discussion started about science, but on the Church's premises.
One of the scholars that came to the University of Paris in the earlier period was Roger Bacon. He came here in 1237, and his work came to have a lasting influence on science. He developed a new perspectives on method in order to study nature.
Roger Bacon argued that we should open up the fields that Aristotle had investigated and look at them in a new and more systematic way, not only observing, but also experimenting. He got interested in optics because he believed that we need instruments to help us look deeper into things, like the microscope, or wider on things, like the telescope. This inspired the new interest in the ideas of the antiquity, which would define the next 300 years in Europe, the Renaissance. This new liberty to study things culminated when Nicholas Copernicus in 1443 published his book on the revolutions of the celestial spheres. Here he presented his heliocentric hypothesis that the Earth circulates the Sun and not the other way around. It was presented as a theory, but would create a lot of controversies for the next 200 years. It inspired scholars to study the planetary system and thereby became the start of the scientific revolution. This was a revolution that would gradually question Aristotle's research. And, as the Catholic Church had identified with Aristotle, it was on the defensive when Aristotle's findings were proven wrong.
And now this church's authority was shaken, and people was bewildered because the church had done something wrong, and Aristotle was the reason. So now the people looked around for some new ground to stand on.
They would increasingly find that ground in science. During the Renaissance, research activities had spread and was done in different places, not only in universities, but at courts and in laboratories. Roger Bacon had discovered gunpowder. Johannes Gutenberg invented the printing machine in 1439, making books more available. Astronomers had redefined the Earth's place in the universe, and Christopher Columbus used new insight in navigation to sail to America in 1492. There was power in scientific knowledge. Kings, princes, and wealthy families like the Medicis in Florence hired scientists in order to invent new things. Science and research was now spread all around Europe.
The scientific revolution that happened during the Renaissance period had convinced people about the power of scientific discovery. And from there on, science gained a much more independent position in society as an independent institution and was allowed to develop on its own account.
The new discoveries in science were made both by better techniques and instruments to observe things, but also through application of mathematics and logic.
In a way, the great authorities leaves the scene, and the discovery of the universe becomes something that everyone can try to participate in. And that was in itself a kind of revolution. And this is a part of this change of perspective which came in the Renaissance, that you put man, the human being, the ordinary human being in the center. Not God, not the authorities, but man, any man.
What follows has been called the Enlightenment period. It's a period where people in general became more educated and more engaged in scientific discoveries. New branches of science appear and new discoveries are made in fields like biology and medicine. It is also a period where the universities develop and where both universities and science are struggling for independence. The Enlightenment period becomes a new start for science. The Renaissance had corrected many of Aristotle's observations. Now was the time to take reckoning both with the whole philosophy of knowledge that Aristotle and Plato had based their ideas on, and also with the Catholic and medieval worldview that had dominated Europe for 1,000 years. The man that more than others would take that role was a French lawyer and mathematician, René Descartes. One of the main things he had to sort out was the relation between the physical world and metaphysics.
Descartes used the metaphor of a tree to describe the relationship between metaphysics and physics. The roots of the tree is like metaphysics. We cannot see them, but we can imagine how they are. The trunk of the tree is like physics, that is something we can observe.
By this argument, Descartes managed to make a divide between our mental existence, our mind, thoughts, religion and beliefs, and our physical existence. This dualism decoupled the study of the physical world from metaphysical speculation. For Descartes, the physical world consisted of mechanics, medicine, and ethics. But Descartes also strived to establish the foundation for metaphysics.
So he was a very ambitious man, and he was certain that he had found the answer. And the answer lay in one single axiom. There's one thing I can be sure of, and that is I am thinking. Even if I'm doubting everything, I'm still thinking, because doubt is a kind of thinking. And because I'm thinking, I know that I exist, and that is my basic axiom to try to understand myself and the world.
The revolutionary with Descartes' philosophy is that it puts man's thinking in the center of everything, not God, not the world, not the divine. Science and philosophy is simply our human mind's attempt to understand the world. Science is human thinking about the world. Thus, he gives science a new start. However, his dualism would become controversial up to our own time.
In the early 17th century, science had to be able to proceed without worrying about religion. So they had a division of the territory. Descartes gave God, the soul, and immortality to religion, and the physical world was the property of science.
The dualism of Descartes would lead to a divide that would set the scene for the further development of science.
We're about to take the train now from Paris to London. It's a journey that takes a little bit more than 2 hours, but in terms of philosophy, we are moving from one world to the other. While continental philosophy continued to be concerned with what Descartes had discussed, namely the epistemological issues related to the relationship between metaphysics and physics, in the British philosophy, one more or less neglected the whole metaphysical discussion and concentrated on the visible world that we can experience, what we will call empiricism.
The man that inspired empiricism in Britain was Francis Bacon. He was a student at Trinity College in Cambridge. In his book, The New Scientific Method, published in 1620, he criticized Plato for his unfounded idea theory, and Aristotle for unfounded categorizing. About Aristotle he wrote, "He corrupted natural philosophy by logic. Thus he formed the world of categories." Bacon called for a new way of doing science, purely based on observation. This new scientific method was called induction.
The perspective of Francis Bacon was not that we study nature in order to understand nature as nature. We study nature from the perspective of being human being. We study it from the perspective of man.
So, Francis Bacon and René Descartes were both part of the Enlightenment period and shared this new vision of science as being man's thinking of the world. But Bacon did not believe that we can gain knowledge from thinking alone.
Actually, the right way of producing knowledge is to thoroughly study, investigate, experiment and so on, and gradually build up knowledge about the phenomena where you get more and more verification of the truth of something. And through that, science could produce truth, and as he formulated also in this book, knowledge is power.
Truths from knowledge becomes extremely powerful. And that is also more or less the slogan of the Enlightenment period. But the disagreement about how to reason about knowledge would be a new, big methodological dispute in the history of science, the one between induction and deduction. And it was a dispute that would continue even after some of the greatest scientific discoveries were made by Isaac Newton in the second half of the 17th century. He became known for being able to give a mathematical description to phenomena.
One was a basic equation of mechanics. And mechanics is a science about how things move when they are subject to forces. The other was a mathematical description of one of the most important forces of the world, namely gravitation.
Modern science had tried to rid itself of metaphysics and superstition. One of the big questions that had occupied minds for thousands of years and led to speculations of divine forces was how we can explain the movement of things, from planets to small objects. With Newton's discoveries, this problem seems to have been solved.
So Newton shaped the science for hundreds of years to come. And he was the founder of physics, which was the valid physics until the 20th century.
Still, in the debate on philosophy of science, the discussion was, how did Newton manage to reach his conclusions? Did his discoveries represent induction or deduction? Philosophers at both sides of the canal would engage in this discussion.
As science grew in importance throughout the Enlightenment period, one started to invest in universities, in beautiful places like here in Cambridge, and to build houses to celebrate knowledge and science, like the Wren Library that we see in the background.
While libraries in the medieval time often had been dark, hidden, and sometimes forbidden to enter, the idea of the Wren Library was openness, space, and light. Knowledge in the form of books should be accessible to everyone.
The window on the south wall behind me is called the Cipriani window. It's a painted glass window designed by Giambattista Cipriani in the 1770s. And it's very interesting because it shows the king who was on the throne at that time, George III, and behind George III is Britannia. Isaac Newton is being introduced to the king by the spirit of Trinity, or the muse of the college. And Francis Bacon is sitting at the bottom right-hand corner, and he's recording the scene for posterity. Now, this is a bit of 17th century fun, because both Newton and Bacon were dead by the time George III came to the throne. It's an allegory of Trinity's greatness, because at that time, and that came at the end of a period where the college had decided to memorialise all its great men, at that time Newton and Bacon were considered the greatest men the college had produced. So this shows Trinity's greatness in the 1770s. And it's a beautiful piece of work, painted glass. The colours change throughout the day because the light in the building is so wonderful. It wasn't a popular window in the 19th century because the Victorians didn't like allegory and they thought the window was a bit gaudy and brash. And there were attempts to have it removed. But thankfully that didn't happen and we can still enjoy it today.
It was a very typical aspect of science in the Enlightenment period that it celebrated its heroes.
This is the death mask of Isaac Newton. This was made immediately after his death. It's all a bit gloomy, isn't it? I don't.
They made it.
They made it, and they took people's hair.
Yeah.
There are several versions of this dotted around.
Even if the Enlightenment celebrated the new heroes, the philosophers and scientists, there was still no agreement among them of what constituted the right way of developing knowledge. The Scottish philosopher David Hume was one of the skeptics among the empiricists. Hume questioned the inductive method. He argued that we cannot know things for sure beyond our immediate observation. An example is the black swan. Even if all swans we observe are white, we cannot rule out the possibility of a black swan. When we form knowledge, we do it as much based on customs and habits as on solid individual reifications from sense impressions. Hume also argued that norms and habits were not necessarily deliberately chosen, but had developed through evolution.
Hume argued that there are two ways in which we can develop knowledge about the world. And these two ways are very often referred to as Hume's fork. On the one hand, we can have knowledge about ideas, and on the other hand, we can have knowledge about facts.
Thereby, Hume rejected Descartes' idea that by doubting I can prove that I think, and thereby deduct truth about the world from thinking.
Hume's great achievement was to show that skepticism cannot be answered within a Cartesian framework. What he didn't do was get out of that framework. And the crucial thing that he could not get out of was that when we perceive something, we actually perceive objects and states of affairs in the world.
At the Continent, one observed a debate in Britain, and the man who tried to reconcile the disagreement between Descartes and Hume was Immanuel Kant. He lived his whole life in Königsberg, but published his articles through the University in Berlin, and managed to be one of the Western world's most central thinkers. Kant's achievement was to bring together different ideas that had dominated his time. He disagreed with Francis Bacon and the empiricists, with their claim that all knowledge comes from impressions and experience. He thought that Descartes was right in pointing out the dualism. On the one hand, the question where thinking comes from. On the other hand, the question how we use thinking in practice. But he did not call the answer to the first of these questions metaphysics. Rather, he defined it as the epistemology. Kant agreed that David Hume had pointed at something important. How do we get from specific knowledge to general knowledge?
Kant argued that Isaac Newton could not have made his discovery based on induction. Time and space that are very central in Newton's theory does not come from induction. If we did not have a concept of time and space a priori, we would not be able to perceive it.
We have two capacities in our reason, Kant argued. We have the capacity to understand general and abstract things, and we have the capacity to understand specific things through sensing and experiencing.
If you adopt the assumption all you can ever perceive are your own experiences, then how do you ever get objective knowledge? How do you get knowledge of things in themselves? And in particular, how to get synthetic a priori truths? And his answer was what he called the Copernican revolution. Instead of seeing our mind having to be responsible to reality, think of reality as having to be responsible to our mind. And then you're off and running. Then you can get synthetic a priori propositions, because what you're dealing with is the capacity of the mind to create representations that give us objective reality. How can there be objective reality? Well, underneath the appearances are things in themselves which we can never know, but we have to suppose that they're there.
Descartes, Hume, and Kant would continue to be main references in philosophy of science in the centuries to come, and their disagreement would dominate the discussion in Europe of what science is. They represented three main directions in philosophical thinking that had impact on the three main discourses in three different countries: Descartes and rationalism in France, Hume and empiricism in Britain, and Kant and idealism in Germany. During the Enlightenment period, society has developed, and across Europe there is progress both in technology and in economic, political, and social institutions. At the same time that Kant sits in Königsberg and thinks. At the University of Glasgow in Scotland, James Watt invents the steam engine, and Adam Smith is sorting out the economic principles of industrial production. Scientific discovery started to materialize in technical and social improvements, thus anticipating the Industrial Revolution. Kant celebrated Enlightenment and gave Frederick the Great credit for having introduced individual freedom, freedom of speech, and the rule of law during his reign as King of Prussia. It is the free thinking among free persons that constituted Enlightenment.
A good expression of the Enlightenment period is this Pantheon building in Paris. This architecture is harmonic and symmetric, and with references to Greek and Roman times, which was the case of the Enlightenment period. And also this was a building that originally was attended as a church, but in 1791, during the French Revolution, it was converted into a celebration hall for French thinkers, and also you could say for French thinking.
We have so far followed European science over a more than 2,000 years history. From its beginning in the Antiquity, through its revival in the Middle Ages, and into the scientific revolution in the Renaissance. From then on, we have seen how science developed as a more and more independent institution, liberating itself from the dominance of the Church, questioning many of the ideas of antiquity, opening new areas of research, and trying to establish a philosophical foundation for scientific knowledge. After the French Revolution, as we move into the 19th century, science would increasingly be influencing society, and the discussion about what is scientific knowledge would continue.